Hello everyone. Today we are going to be working on talking about different aspects of functions. So we have a lot of things we're going to be covering today. We're going to learn about identifying maximums, minimums, x-intercepts, y-intercepts, increasing and decreasing intervals, domain, range, and end behavior. I know that sounds like a lot, but most of these things are really easy and they all go together. So the first two are kind of common sense. A local maximum just means that it's a point which is higher than all the other points in the immediate vicinity of the point. So for example, on this graph here, this would be an example of a local maximum. And then a local minimum is a point which is lower than all the other points in the immediate vicinity. So this would be an example of a local minimum. Some graphs have only a local maximum, some have only a local minimum, some have both, and some have neither. So we're just going to look at these graphs and determine which type they have. So if we look here on number 1, we've got a high point up here, so that would be a local maximum. If we look at this next one, it's tempting to think that right here is a local maximum, but since we've got a flat line coming to it, that point's not actually higher than the points near it, so it's not a maximum. But if we look down here, we have a minimum. Right, and then for this next graph, we can see we've got a maximum, a minimum, and then another maximum, so this is a both. Alright, the next thing is we need to be able to identify intervals of a graph. Interval is a specific part of the graph function given two endpoints in terms of x. Remember that x always goes from left to right, and we have two ways we can write it. So down here I've got one way using inequalities. The other way we can write it is interval notation. I'm not going to get into a lot of details as to what interval notation is. I'm just going to tell you what you need to know for this. For interval notation, if we wanted to rewrite this in interval notation, we're going to use parentheses, and it's going to be from -infinity to 0. So this one, if we wrote it in interval notation, would be 0 to 5, and the next one would be 5 to infinity. So you'll learn more about interval notation in pre-calc, but for right now, this is just so that you know. You can write, whenever I ask you for an interval, you can write it either way, that's okay. The nice thing with the interval notation is it's a little bit shorter. So we want to look at this graph and identify which interval is which. So when we talk about -infinity is the left end of the x-axis. So that means we're starting way at the beginning of the graph here. So if we're going from -infinity to 0, that would be this interval right here. So that's interval A. If we're going from 0 to 5, we already dashed off 0, and 5 is right here, so that would be interval B. And then from 5 to infinity, when I talk about infinity, I'm talking about the right side of the graph. That's this part right here. So the reason we talk about intervals is because we talk about whether they're increasing or decreasing. Because as you get into pre-calc and calculus, you'll need to know a lot about what it means when graphs are increasing or decreasing. For now, we're just trying to figure out where they're increasing or decreasing. First thing I want to do is go through, and I'm going to put dotted lines through all of my local mins and maxes. Because wherever there's a local min or max, that's where the graph is going to switch between increasing or decreasing. Now, to figure out if it's increasing or decreasing, the easiest way is to start at the left side of that interval. So I'm going to start over here, and then draw an arrow that follows the graph to the right. We can see this arrow is going down, so that means that part is decreasing. Then if we go to the next piece, if we start at the left side and follow the graph, it's going up, so that means it's increasing. And then again, if we start at the left side and follow the graph, it's going down, so this interval is decreasing. oops, I forgot the N there. And if I start at the left side here and follow the graph, it's going up, so that is increasing. All right, now the next thing, this is the part that can be a little tricky for people, so make sure you pause as necessary or rewatch this section if you need to. So end behavior. You're always going to see this notation down here when we're talking about end behavior. What this says is as x approaches infinity, f of x approaches what? So when I'm talking about x approaching infinity, that means that I want to look at the right arrow of the graph. So if I look at that right arrow, it's pointing up. Since it's pointing up, that means that graph is forever going to keep going up. So that means that f of x is approaching infinity. Now, if it asks me as x approaches negative infinity, I'm going to be looking at the left arrow of the graph. So that's this guy over here, and that one's pointing down, so that means the graph is going down forever that way, so it's going to be approaching negative infinity. Alright, then some more practice like what we did yesterday. If I want to find f of negative 5, that's right here, that's at 0. F of negative 2, it's right here. F of 0 is at negative 5. And f of 4 is 0. So then it asks what the x-intercepts are. Remember, x-intercepts is where it crosses the x-axis. So that would be these 3 points, and you want to write those using coordinates. So negative 5, 0, negative 2, 0, and 4, 0. Then it asks for the y-intercept. That's where it crosses the y-axis. And that would be right here at negative 5. So it's 0, negative 5. Then I have a question I want you to think about and answer on your own. We'll talk about it in class. You must answer this question, have something written down, some idea, in order to get credit for these notes. Now I want you to think about and explain why there can be multiple x-intercepts, but there's only one y-intercept. I want you to think about that and think about what we know about functions. That should be a pretty good hint to help you out. Alright, next thing we have is domain and range. Domain is all of the values that can go into a function. So this is the set of all of your x values. Range is all the values that can come out of a function. So that's the set of all your y values. So we're going to go back actually to the graphs we've already looked at, and we're going to identify the domain and range. So if we look at this graph, typically your domain is going to be all real numbers. And all real numbers just means that it can be any number that's not imaginary, which we'll learn what imaginary numbers are later. But so the domain is all real numbers, and you can tell because there's no restrictions along your x-axis. Now your range, you're going to want to look at your end arrows. If the end arrows are pointing in the opposite directions, that means that your graph is going forever up and down, so it's going to be all real numbers again. Alright, let's look at this graph here. So again, our domain is going to be all real numbers, and I forgot to say on the last example, this little symbol I wrote means all real numbers. You can write out all real numbers or use the symbol. Now if I look at my range, we want to look at both end arrows. This time both end arrows are pointing up. So that means it's going up forever but not down forever. So the range, I'm going to look right here. I'm going to say this is negative 5. The graph is never going below -5. So that means our range is all y values that are greater than or equal to -5. On a graph on a quiz or test or in your homework, you will see a number there. You wouldn't have to make it up like I did. I just forgot to mark that. All right, if we look at this guy, again, we're going to have a domain. That's all real numbers. And then if we look at the range, our end arrows are going up and down. So that means we're going to hit all of our possible y values. And I think that's the last one I want to talk about. Yep. All right. Going back to here. So we're going to put all of this together. And I believe this is our last problem. Yep. All right. So first, does the graph have a local maximum, neither, or both? It has both. And it asks, is the point -8, 4 a local min or max? So that would be a max because it's a high point. And it asks about 3, -2. That's a low point, so that's a min. And it asks if the function is increasing or decreasing along the interval -8 to -4. So -8 starts here, and -4 ends here. If we draw in an arrow from left to right, it's going down, so that means it's decreasing. And then it asks about the interval 15 to infinity. So infinity just means it's going to keep going. If we start at the left, draw in our arrow, it's going down, so that's also decreasing. Then it asks about between 0 and 3. If I start on my left side and draw in the arrow, it's going down, so another decreasing interval. And then it asks about -4 to 0, so that starts here and ends here. If I start on the left side, my arrow is going up, so that one is increasing. Now it's asking about the end behavior, so it says as x goes to infinity, that tells us to look at the right arrow, and it's pointing down, so that means it's going to -infinity. Then we have as x goes to -infinity, so I want to look at my left arrow. That's also pointing down, so that means it's going to -infinity. Then as x approaches 9, when I ask about it approaching a number, I'm just asking what the y value is at that number. So at 9, the y value is 10. All right, then it just asks for the value of f of -4. So -4 is on the graph right here, and that goes with -3. Then I've got f of 0. That point is right here, and that's at 6. Then finally it asks all the values of x for which the function equals 0. That really means what are the x-intercepts, or zeros. So if we look here, we've got -10 and -7. -1 and +1. And 5 and 15. Alright, that's it. If any of that was confusing, please make sure that you go back and watch the part of the video again to see if that helps, and then jot down any questions you have so that we can go over them in class tomorrow. Alright, good luck.